Okay, yes, excellent. Thank you very much. Okay, so thank you, of course, to everyone in the infrastructure group. We had a very good discussion, I think. We started with, as usual, with obstacles. So talking why things can't be done. And one of the main things was, of course, funding, money, other regulations, non-noise regulations, safety and all that sort of thing. And at the same time, we've got traffic growth going on, so there's a need for noise reduction on the infrastructure. And there's all sorts of risks. So if you test something new, there's usually some sort of risk involved, which is an obstacle. Very importantly, if you want to test something new, you often want a nice test track with some availability. So you want a period of time over which you can test your innovative noise control measure. And this is more and more of a difficulty because these test tracks aren't available. So how do you overcome these obstacles? Well, I have a few open doors here, but obviously cheaper solutions, identify where the bottlenecks are in the whole process, and make capacity available in terms of people to sort this out. What was also mentioned was the streamlining of standards and organization. So if it's not properly organized within a company, for example, railway company, if you don't have people communicating with each other about the critical bottleneck, then things won't work. So you need stakeholder cooperation and communication. That should be both at an internal level and external level. And of course, you need decisiveness. So if no one's prepared or able to make a decision on doing something, it won't happen. The word holistic was also mentioned, which I found quite interesting. I've heard that in other stakeholder discussions in the road vehicle sector. And when they talk about vehicle noise limits, and they say, oh, we should look at it holistically. Now that sounds very nice, but from what I've seen, it can also be used as an excuse to say, well, it's not our problem, it's the road's problem. So there's two sides to the holistic approach, but okay, it was agreed that that's important here. And what you need to do for further noise reduction is you need to include all of the aspects and impacts. So not just from a noise point of view. And the trouble is not all of these are known. So when you embark on testing of noise reduction solutions, you may be open to failure or some risks or things which really will be identified which may not lead to success. Getting to noise control measures, we talked about rail grinding. That's a well-known method to reduce the rail roughness, of course, and to reduce the noise. The problem with that is the issue of scheduling it, coordination, and of course, optimizing it for noise. So of course it can be done, but you need to go through a process to get that working properly. So in terms of solid noise reductions, several things were mentioned. Of course, there's many different options, but ideally, as an infrastructure manager, you'd like to have a fairly cheap and straightforward means of reducing the noise by another 10 dB. That would be really helpful. So a number of things were mentioned, which are probably you're probably familiar with. So low noise pads, which we presented tomorrow, I believe, diffractors, meta materials on barriers, rail grinding specifically for noise, and most importantly, covering the whole system of track and vehicle. So that's also a very well-known principle. You can't normally just tackle the vehicle or the track. You usually have to look at both. Another problem, well, talking about problems and obstacles, of course, doubts about effects. So there's often doubts about how well something will work. And one of the ways of dealing with this is to apply monitoring of vehicles and tracks, both of them, and to learn from the findings. So this is already ongoing in some countries, but probably a lot more can be learned from it. And it's one way of convincing people that things can actually work in terms of noise reduction. Another point that was mentioned is shared responsibility for noise. So there has to be a felt responsibility amongst particular stakeholders to get things moving. And then finally, noise access charging was mentioned, at least not in the sense that we know it. It was suggested to compare with what is done in the aircraft industry, or the aircraft, I should say the aircraft sector. So a paper passed by based on measurement. So noise differentiated access charging, as you may have heard of it, is based purely on component principles. So you would get a lower noise access charge if you have quiet brake blocks, for example. But the suggestion here was to take an actual measured pass-by level as a basis for noise access charging, because that would probably set in motion a number of actions to deal with the real noise levels. So I think I've covered everything. If not, I'm sure someone will let me know. And thank you very much.
We will start again like we did with other sessions. Any comments, questions? Yes?
Yeah, thank you for both presentations. Just Micahel, to you. So, of course, I think everybody in the room has already cooperated with any infrastructure manager. We are not completely free of the infrastructure manager's view, but I'm very interested if you have found out from your group discussion the core bottleneck, why all these innovative approaches from the last decades have, to be honest, not really became reality on the track. So when the track is renewed, it has no acoustical approach at all today. What's the reason on that? Did you have an idea on that?
Well, I'm not really sure what the core reason is, but I mean, several were mentioned, yeah? So besides the cost and risk and everything, first of all, more than one player has to be involved. So everyone who is required to achieve the final result has to be on board and agree, and someone has to take a final decision to do it. And this distinction between infrastructure and vehicle, of course, is one of the splits which occurs. So I think those are some of the reasons, yeah.
Urs, what do you think about that?
When we build a track today, it's built for 50 years. And when we put the sleepers and the rails in, we need to be confident that the solution will stay 50 years more or less maintenance free. Because whatever we do, the cost of the material that we use is almost neglectable. We have so much cost for safety, for access of the track, for actually building the things. It's almost never about the price of the piece. It's always the cost installing it, and if it has to be removed after 5 years of life and then the old stuff has to go back, it's just a huge financial risk.
I mean, I think there are probably additional reasons too, like some of these new products, they cause problems with diagnostics, for example, right? Or with maintenance.
That's something that was our issue with the rail dampers, that they were in the way of our optical detection system. And we also cannot forget the third party that we need. We cannot go from research to track. We always need a supplier in between. So when a research project is a success, a university cannot supply us for the next 20 years with a stream of that product. It's right. It has to kind of gradually evolve through the chain. When there's a good project, there needs to be a supplier that makes it, that improves it. And we are infrastructure managers. We are not producers of rails, rail pads, sleepers, under sleeper pads. We always also need that covered.
Thank you. Any other questions? Yes?
Hello, Jaume Soler from Center Spain. It's not a question, actually, it's a remark. You have talked about the spark noise, and you have mentioned that it happened at low temperature. I think that this is so because you are in standard speed. At high speed, at 300 kilometers 1 hour, you can have this noise in whatever temperature. And I remember, for instance, a test in which we went from 300 to 350, and this shift in speed was dramatic with respect to spark noise. I remember being beneath the pantograph at 350. It was a night test. It was a complete spectacle of sparks. So this is the point is a phenomenon that has get few attention because it's random. It's difficult to measure. It's really challenging to measure, and it's challenging to separate from pantograph noise. But it's a topic that I think in the future it's going to be an interesting field of research. That's that.
Thank you. I also heard that you can avoid it, especially with parch trains, when they, I'm not sure about the correct term in English, when you use the bad current, the feedback current, that when you increase that and then the line heats up and the water melts. But that shouldn't be the normal way of doing that.
Okay, we would have time for maybe one more question. Yes, this.
Yeah, I have a question for Mr. SBB. Sorry for your surname. Yeah, when I see all the source, I'm thinking about door audible signals. Currently, you have to be compliant to the TSI for the noise levels and the frequency amplitude. But have you tested during your research to change the functionality of the door audibles and use adaptive signals?
The adaptive signals?
Yeah, it means that adaptive signals, it's on a door, you could use some door adaptive signals which can reduce the noise emission for the door.
Yeah, that's also what we then concluded with our colleagues from the operating department. They had, I think, one possibility was just always blast at maximum noise level. But then it's also, it can be adaptive, but to be adaptive, you need to have incorporated a sensor to measure the background noise level and then adapt the signal. I think now that's how they solved it.
Okay, thank you. Now the very last question. Ward?
It's maybe not a question, but maybe a solution for getting acoustical solutions into the track is what we try to do at the Low Noise Pad project is from the beginning of a project, working together, not everybody on his island, but getting the acoustical engineers together with the track engineers and try to work together from the beginning of the project until the implementation and not stay on the island. Go away from the island and work together.